Okay, so Git is used for version control. And in general, this means tracking changes in your code base and giving you the ability to revert to previous versions of the code. And this I'll explain more in detail down the line. But first, let's discuss the purpose of using version control in a program. So even if you haven't used Git before, you've likely experienced version control in something like Google Docs. So let me show you the evolution of these slides. If you go to the history, you can see what changes were made in each session, by who, and even revert back to previous sessions if needed. So just for an example, we can also go to GitHub to see how they track changes. So in this case, what's highlighted in red would be what's deleted from the file, and what's highlighted in green is what's added to the file. So GitHub works like Google Drive in that it's where files can be stored in the cloud. So in this case, Git repositories will be stored in GitHub. So to break down what is a repository, when you have a project that you want to track and have initialized Git in that project now becomes a Git repository. So just for more examples, this is the QWeb GitHub repository place. That's where we put all our repositories. So when a repository is uploaded to GitHub, it is now referred to as a remote repository, since it's not just on your local computer anymore. And now anyone you let can access it. So let's go to this one here. And you might be thinking that it doesn't seem that helpful right now if you're used to working by yourself. But in the real world, you'll likely find yourself working in teams for work, school, hackathons, etc. In fact, you'll be working as a team in QWeb to develop a project together. So a version control system like Git is needed to resolve things like code conflicts between all the developers and revert back to older versions of the code if a new bug appears. So as you've seen from GitHub, that's how we share our code, even if we're all working on our own computers. And we accomplish this by pushing or uploading your code to GitHub. So what this means is transferring the code that you have locally, which means on your computer, to the remote repository to be stored on GitHub. And someone else can then download your code, referred to as pulling, and merge or combine with what they have locally on their computer. Are there any questions so far? So pulling and pushing often result in merge conflicts, and a conflict can occur when you and another person have different versions to the same part of the code. So what you don't want to do is completely replace one person's version without first taking a look at what's different. So for example, in this random code I got from the internet, this is what a merge conflict looks like in VS Code. So if you are pulling from GitHub, the part highlighted in blue is likely a teammate's code. The changes incoming to yours, and the part highlighted in green is your code. So you can see in this example here, the only difference between the two is that there's an icon element in your code that your teammate does not have. So this can happen, for example, if you both start with the same base code, so like this bottom code, for example, but then you decide to make changes later on, like add an icon that your teammate won't have. So in this case, you can just click on accept current change in VS Code, and they automatically update the file to keep just our version, so just this green part. And conversely, accept incoming change means to keep theirs, and accept both means to keep both of ours. So another feature of Git is branches, which are like separate versions of the main repository. So as you can see in this diagram, when the main or master branch splits or branches off, a copy of it is created so that someone can then alter the copy without actually changing the original itself. So as an example of an application, because I'm a junior developer, all the new code and features that I implement, I edit to the Git repository under my branch. And there are a few other junior developers working on other features, and they have their own branches. So that way, we're all working on, again, a copy of the code without potentially causing something to go wrong with the original. And then at the end, the senior developer looks through all our branches makes adjustments as he sees fit. Then he attempts to combine or merge our branches with a default branch to get the final product. And by the way, each of these circles represents like a commit or a save of your code. So for example, if something goes wrong in this commit after we merged in your work, we can revert back to this commit where everything is working and debug from there. So now that we know the basic concepts of Git, let's actually do a small little demo on how we can work with it. Any questions so far before we move on? So let's say I have this simple project here that I want to use Git in. So you need to have Git installed on your computer to use these commands. So I can open up a terminal and start a new Git repository using the command git init. And there we go. Every time we now choose to make a commit, essentially deciding to save a version of our code, Git tracks this locally. So how exactly do we save code? So first we need to add the code to what is called the staging area, or you can add So the command is git add, and you can add everything that's changed using the period, or you can pass in the name of the file specifically that you want to add to the staging area. So in this case, we'll just add everything, which is just index.html anyways. And now it's added to the staging area, but it's not yet committed. So you would commit it to the repository by using git commits. And then -m, mflag, and then put in a commit message. So I'm just going to do something simple like first commits. But in general, these should be more detailed because these are like the only way you can differentiate between what's changed. Okay, so now everything is set up in our system, but to work with other developers, you need some kind of remote cloud storage kind of thing to actually host the code. So that's where GitHub comes in. So let's take a quick look at GitHub UI first, just to get familiar with it. When you log in, you likely see your dashboard like this. Your repositories, which are remote, are on the left. And you can click new to easily create a new one. It's pretty intuitive. You can click on your icon to go to your profile. So let's go ahead and create a new repository. And by the way, if you want to add your teammates to the project, you go to settings, manage access, and then search up the usernames of your teammates. This is needed, otherwise they won't have permission to push to the repository. So anyways, let's go back. What I like about GitHub is that they kind of give you the commands you need to connect your code to the repository. So we can go back to our code. And by the way, command line means the terminal that we're working with. So we can go back, copy the first line. So what this is saying is to add a remote branch in your Git repository and attach it to this on GitHub right here. And you can see the URL varies depending on what your repository is called. So, okay, there you go. That should be attached. And the second command means to create the main branch, basically. So we can copy that, paste that in, run that. And lastly, we can push what we have to the main branch in origin, which is the remote repository. So we do that. Okay. So now if I refresh, I should see what I've committed here. And if I go into this file, we can see that it's the same as what I have on my computer. And if I wanted to make a quick update to the file, for example, like I changed my favorite color to blue, so I can save, and then I would repeat the same steps to add it to the staging area. So git add period to add everything, and then git commit -m changed color. Okay, so if we refresh this here, nothing has changed. This is because we haven't actually pushed our changes that we've made locally to the remote repository on GitHub. So we need to git push origin, and then the branch you want to push to, which is just main right now. And we refresh, and we can see our changes. Any questions, part 2? So if I wanted to create a new branch, I run git checkout with the B flag and put what I want to call it. So for example, branch 1. And so as you can see, switch to a new branch, branch 1. So what this does is it tries to switch to that branch. And if it doesn't exist, then it creates one. So if I created another one, and I wanted to switch back to branch 1, it would just be this, git checkout with the branch name. And if I wanted to see all the local branches, I would run git branch. And we see all our branches here. If I wanted to see my remote branches, it would be git branch with the R flag. And you would see origin main. So to delete branches, you just do git branch again with the D flag and the name of the branch you want to delete. So let's delete branch 2 here. And if I do git branch one more time, we see that it's gone. Something to note with Git is that when you delete anything, you need to be careful because some people have deleted their entire repositories by accident. That would like erase all the records that are being tracked. So moving on, let's add and commit all the changes that we have right now to this repository. So I'll just do git add, git commit, added branches, okay, nothing to commit. So if I just push to origin and branch 1 this time, now we can see in our repository, the new branch is added here. And we can see, well, right now they're the same, so there wouldn't be any difference, but if there were differences, then you could easily switch back between the two here. Okay, so to pull someone else's changes, you run the command git pull origin and the branch name you want to pull from. So if we wanted to pull from main, it'd be git pull origin main. And we don't actually do this, like make changes in GitHub, but just for the sake of this demo, I'll make a quick change to this file here. So if I change my line to yellow, commit. So now we can see it says yellow here. Back locally, it still says blue. So after I run the git pull origin in the branch, actually, wait. Oh, I think I'm on branch 1. Okay, git pull origin branch 1 then. So now we see yellow here, just like we've changed in GitHub itself. And this is also like when you're pulling, where you might have to deal with merge conflicts, as we've seen earlier in the tutorial. And another thing I wanted to touch on is how to contribute to an existing repository. So in your groups, likely someone would create the base React app and then upload it to a remote repository on GitHub, much like this. So they would then need to add the rest of the team as contributors, or else they won't have the permissions again to push their changes to the repository. So let me just clone someone else's. This is React 1 written by Bobby. So I would copy the HTTPS link. And then here, I'll just make a new folder to put everything in. So React 1, I just call that. Open up a terminal for this. And the command to get the repository, just like clone it, is git clone with the HTTPS link. So now when we open up this folder, we see everything that's in this repository in here locally. So another thing to note is if you try to run this code right now, if I npm start, you would get a bunch of errors. And this is because node modules, comprising of all the packages and dependencies that allow React to work, is commonly excluded from a remote repository due to its large size. So that means the user has to download all of them themselves. So you just run npm I, so npm install, to install all the dependencies that are listed in package.json. So that's all these libraries here. And after everything is installed, the app should run just fine. And if you had any other secrets like API keys, so they are basically access keys that allowed you to use services that you don't want anyone else to have, you can just put the name of the file. So sometimes it'd be like a .env. So you can put the name of the file containing those keys in the git ignore file. So much like the node modules, files listed here are not staged or committed to GitHub. And something similar to cloning is forking a repository. So we can go ahead. I already forked it, but what this does is it creates a completely new independent copy of someone else's code and makes you the owner so that you can play around with it as you want. Yeah, so I own this basically, and I can commit anything. I can't commit to Bobby's right now because I don't have permission for that. But since I forked this React one, this is now mine and I can commit to this one. So wrapping up, since this is a short and sweet tutorial, memorizing the Git commands definitely comes over time. I've linked resources in these slides, and there are cheat sheets that exist if you need them. As for the mini project this time, I just want you to play around with Git, get familiar with it and the commands, create a repository on GitHub, and push something, for example, the mini projects for other tutorials to it. And then just for practice, make a branch, push to that branch. And if you wanted to, you could ask someone else to make you a contributor so that you can push to theirs and then just deal with merge conflicts that way. And that's everything for this tutorial. So thank you all for coming, and I wish you the best of luck for your exams. So I'll open up the floor for any final questions.
Awesome. Yeah, I just wanted to pop in for one more quick word, but before that, I'll let you guys kind of like ask any questions related to the tutorial content as well. Just give a minute or two. Okay, sweet. I just want to check really quickly. This is actually a mistake I made because in the announcement earlier, I asked everybody to make a GitHub account. I didn't actually ask if you guys had Git installed already, which I completely forgot was the thing. So just checking if anybody didn't have that installed already or thought they would have trouble with it, we could probably help you out now. So it's anybody who doesn't really know what they're doing in terms of installing Git and just kind of like, oh, I don't really know how to get started because I don't have this software installed. Okay, sweet. Sounds like we're all good. So yeah, just like Jade said, thanks for coming to all the tutorials, guys. Had a great time being on Q of Education with all of y'all, and good luck on exams. Jade, is there anything else you have to end it off on?
That should be everything from my end.
Awesome. All right. Thanks, guys.
Thank you.